Well, here we are again, number 9. We're going to do some differentiation to start with. So first of all, we're told that y is this delicious little thing here, 2x to the 5 plus 7 plus 1 over x to the 3. And we just look down, we can see that we're going to be asked to differentiate it and integrate it. So before we go any further, we're just going to get this out of fraction form here. So this is going to turn into y is equal to 2x to the 5 plus 7 plus x to the minus 3. So that's the first bit. Now I can differentiate it. So dy by dx equals, so I bring the power down, so it's 10x to the 4, the 7 disappears, and then it's going to be plus minus 3x to the minus 4, and it says simplest form, so we just tidy it up, 10x to the 4 minus 3x to the minus 4. And that's my differentiation done. Now for the integrating. So the integral of y with respect to x. So we're going to integrate 2x to the 5 plus 7 plus, getting carried away with myself here, plus x to the power of minus 3, and we're going to do that with respect to x. So now I'm actually going to integrate it. So I've got 2x, the power goes up and I divide by the new power, plus 7, it goes from x to the 0 to x to the 1, divide by 1, don't normally write that, plus, now a bit trickier here, when minus 3 goes up it turns into minus 2, and I divide by minus 2, and don't forget the waitress joke, plus c. But I need to simplify it, so 2 over 6 becomes a third, so I've got x to the 6 over 3, or you could have written a third of x to the 6. 7x is pretty simple already, and then the minus, I'm going to bring that up here because something divided by a minus is a minus, and then I've got x to the minus 2 over 2 plus c, and there we go. Now on to question 2. Question 2 is all about indices, and first of all we're going to find the value of 25 to the power of a half, which hopefully you all know is the square root of 25, which is 5. Part B, a little bit more challenging perhaps. There's 3 things in here. We've got a negative, we've got a fraction, and we've got a power. So let's deal with the negative first. That means it's 1 over, and it's 25 to the power of 3 over 2. Notice how I've just taken the negative out and switched it to what it means, which is 1 over. Now, the next thing I'm going to do is I'm going to deal with this fraction, and this is a half, so it's 3 halves. So that is a square root, so it's 25, and the 3 is left on the top. So we can see now easily that root 25 is 5, and 5 to the power of 3 is 1, 2, 5. And that's that one done. Okay, bit of core 2 work now. So question 3, find the remainder when f of x is divided by x minus 1. Now you might be tempted to actually do the division, which is okay, but there's a much quicker way. You can use the remainder theorem. So we take this and we substitute x equals 1 in. So we find f of 1, notice it's the opposite sign, this is minus 1, and that's because 1 minus 1 will give you 0 in the bracket. And the number that pops out will be the remainder. So it's 1 to the power of 3, minus 7 times 1 to the power of 2, minus 5 times 1, plus 4. And you stick that into your calculator and you'll get the number minus 6 out. So you can see the remainder is minus 6, which means that this is not a factor. Not a factor. Okay, for it to be a factor this would have to be 0, and of course this is where the next bit of the question is going. Use the factor theorem to show that x plus 1 is a factor. So we're going to substitute minus 1. So f of minus 1, which gives us 2 times minus 1 cubed, minus 7 times minus 1 squared, minus 5 times minus 1, plus 4. And of course you've got to be very careful with your signs here, and if you are going to use a calculator, just make sure all the negative numbers, when you substitute them in, you put them in brackets, and that comes out to 0. Therefore x plus 1 is a factor. And then we come on to the last part of the question where we've actually got to factorise the whole thing. So we know one factor. Here's our first factor. So there's two ways to get this, but the easy way is to just divide this polynomial by this number, by this expression here. So that's what we're going to do. So let's go for it. So we're going to take our x plus 1, and we're going to divide 2x cubed minus 7x squared minus 5x plus 4. So here we go. X is going to 2x cubed, 2x squared times. And then we take this and we multiply it by the x to get 2x cubed, and by the 1 to get positive 2x squared. And then we subtract, so those two go to 0. Minus 7x squared minus 2x squared is minus 9x squared. And then we bring the minus 5x down. And we do it again. We take the x and we say x is into minus 9x squared, go minus 9x. And then we take the minus 9x and multiply it first by the x. And then we take the minus 9x and multiply it by the 1. And then we subtract. And those two go to 0. We're very careful here. Minus 5x minus 9x gives us positive 4x. And then we bring the plus 4 down. And finally, x is into 4x, go positive 4. We take the positive 4 and we multiply it, and it gives us that, which is just as well because there should be a remainder of 0 because this is a factor. Now what that means is that we know now that f of x is equal to x plus 1 times 2x squared minus 9x plus 4. But it said factorise it completely, which means we've got to factorise the quadratic part. So we've got our x plus 1, and then this factorises into 2x minus 1, x minus 4. And of course you would be crazy if you didn't multiply that out to check in an exam. Absolutely crazy. Completely barking. Utterly bonkers. Now, question 4, circle question. They've given us the equation of a circle here. How do we know it's the equation of a circle? Well, it's got an x squared and a y squared in it. Unfortunately, it's not in factorised form, so we're going to have to do that in a minute. It's not a surprise. They ask us for the coordinates of the centre and the radius. So the first thing we're going to do is we're going to take this and we're basically going to rearrange it so we've got our x's together. So we've got x squared plus 4x, and then we've got our y squared minus 2y, and we'll put our 11 over there. And now we're going to do completing the square twice now. So we've got x plus 2 all squared, and remember you subtract the square of this, so subtract 2 squared, plus y minus 1, so it's half of this, remember, and then we subtract that squared, so we subtract 1 squared, and that equals 11. And then clearly that's minus 4, isn't it? And that's 1. So we've got x plus 2 squared plus, oh, forgot my squared there, y minus 1 squared, and then we're going to add the 5 over to get 16. And that is the equation of the circle in a more useful form, because it's going to let us get 2 marks for the centre. So the centre is at minus 2, 1. Notice I just took the numbers out of the brackets and reversed their signs. And then the radius of C, well, the radius is the square root of this number here, so it's the radius, it's the square root of 16, which is 4. And that's a very easy 4 marks. Now, we're now asked for the coordinates where C crosses the x-axis. So, crosses the x-axis, that is telling us, sorry, the y-axis, it's telling us that x equals 0. Because when you're on the y-axis, that is the line x equals 0. It's also telling us simplified surds, that means use the formula. Don't bother trying to factorise. So off we go. So we take our equation of a circle and we're going to stick x equals 0 into it. So I've got 0 plus 2 squared plus y minus 1 squared equals 16. And off we go to town on that thing. So that's going to be 2 squared, so that's 4, plus, be careful here, remember there's a double bracket, there should be 3 terms coming out of this. Don't make the schoolboy error of just squaring the y and squaring the minus 1, or your poor maths teacher will weep bitter, bitter tears. There we are. So that gives us y squared minus 2y minus 11 equals 0. And then we're going to stick that into the equation. So y is equal to minus b, so minus b so there's our minus b, and then we've got plus or minus the square root of b squared minus 4 times a times c all over 2a. And you should get plus or minus root 48 over 2, which will simplify down to 1 plus or minus 2 root 3. Apologies, I have trouble with this. So we've got our 2 crossing points at 0, 1 plus 2 root 3. God dear, bit of a brain blank going on here. 2 root 3, and the other one is 0, 1 minus 2 root 3. And that's that. Hope it went well for you.